Hello, we are going to do experiment number 4, Dumas method. Dumas method is used to determine the molar mass of a compound. In order to determine the molar mass of a compound, we use the vapor state. That is, a given liquid is converted into its vapor, and then the vapor is then allowed to cool down to room temperature, and then we are going to calculate the molar mass. In order to do this particular experiment, there are certain gas laws that you should be familiar with. And they are the Boyle's law, which says that the pressure is inversely proportional to the volume when the quantity of gas and temperature is kept constant. Second law, Charles' law, which says that the volume of a gas is directly proportional to the absolute temperature when the quantity of gas and the pressure is kept constant. Third, Gay-Lussac's law. The pressure of a gas is directly proportional to the absolute temperature when the volume and the quantity of gas is kept constant. And lastly, the Avogadro hypothesis, which says that the volume of a gas is directly proportional to the number of moles present when the pressure and temperature are kept constant. Combination of all the 4 laws gives rise to what we call as the ideal gas equation, that PV is directly proportional to NT. In order to remove the constant of proportionality, the ideal gas equation is written as PV is equal to nRT, where each of the terms have the following meaning and units. First, P is the pressure in atmosphere, V, the volume in liters, N, the mass of the substance divided by its molar mass, R, the gas constant, whose units are in liter, atmosphere, mole, Kelvin, and T, the absolute temperature. The value for R is obtained under the STP condition. STP conditions are conditions in which it states that the volume occupied by a gas at standard pressure of 1 atmosphere and standard temperature at 0 degrees C or 273.15 Kelvin is a constant for 1 mole of a gas. Knowing that, we can easily calculate the value of R. The value of R depends upon the units of pressure and volume used, but generally we use liter, atmosphere, mole, Kelvin. Then, and with that introduction, I'm going to go and share my experiment with you so that I can quickly demonstrate. Now, if all the statements and words that I informed you about, they are here under introduction. Boyle's law, Charles' law, Gay-Lussac's law, and if you go a little bit below, you will see the Avogadro number. The gas constant is R, and so you can see what it is and how it is to be determined, and the experiment performed. So how do we do that? We go to the procedure. In order to do the experiment, we get a Dumas bulb. The Dumas bulb, note down the volume of the bulb in milliliters and convert it to liters and enter it under observation table. Then I'm going to right click on the Dumas bulb, get to the chemicals, select acetone, and I'm going to put a small amount of volume so that I can complete the experiment quickly. And there you have it. But before I do that, I forgot something. So let's go back, get an electronic balance. An electronic balance because it says mass of Dumas bulb. So put it on it, record the mass. So you have the volume in liters, the mass in grams of the bulb. Now you put the chemicals, get the chemicals, select acetone, and please do not use the volume that I am using. Follow the book instructions. There it is. Now I go back to the equipment, I get a 600 ml beaker, add 500 mLs of water in it. You can select 500 mLs of water at room temperature, and then insert a thermometer inside it, and then get a hot plate. Get a hot plate, keep it below the bulb beaker, and then lower the bulb to just properly on top of the beaker. Highlight both, combine, and then place the bulb, the beaker, on top of the hot plate. Right-click the mouse and say maximum heat and let it start heating. As it is going on heating, you can write up your lab report and also complete the homework that has been assigned, and make sure that the pictures of each of the steps are copied and pasted into your Word document. Now we wait till the temperature of the water reaches 100 degrees Celsius, and much before 100 degrees Celsius, all the liquid which is present in the Dumas flask must turn to vapor. After it turns to vapor, we have to allow the liquid to cool down, the flask to cool down in the hot water bath for 1 or 2 minutes. Then take the hot plate beaker out of the away from the hot plate, allow it to cool for some more time, then remove the flask and let it cool completely to room temperature before you record the mass of the vapor and the bulb. Now remember that the bulb was filled with vapor at 100 degrees. So when it is cooled down to the room temperature, part of the vapor will condense back. And it is the mass of the condensed vapor and the vapor that fills the bulb that you're going to record under 3 as mass of Dumas bulb plus condensed acetone. And then the difference between the mass of the empty bulb and the bulb with the acetone condensed will give you the mass of acetone that is obtained. Using that mass, you can use the PV is equal to nRT, substitute the number of moles by its definition, that mass in grams over molar mass times RT. Then PV will be equal to WG over M times RT. And now readjust this equation to M is equal to W in grams RT divided by pressure times volume. When you use that equation, you can get the units of molar mass in grams per mole. And now you can see that the liquid is started to boil. And remember, always make sure that in the experiment, the liquid starts boiling. If the liquid does not start boiling, that means there is an error in your setup. So empty and drain out everything and restart the whole thing all over again, so that you can complete the experiment very quickly and fast. But no matter how fast you try to complete it, you cannot increase the heat, because on the hot plate it says as maximum heat. So let the temperature go up. Make sure all the liquid has turned to vapor, cool it down, and then record the mass that is required. And so we wait for a few minutes to cool. And so we still wait. And so usually during this wait time, I would suggest you open a Word document, open the template, start typing up the introduction, how the procedure you did, what are the objectives of the experiment. So go on introduction, objective, material, equipment, procedure, observation tables. You can start partially filling it up. And then after the observation table and prior to the calculation, copy the pictures and paste it in there, so that the lab report is almost ready to go as soon as the last mass comes in. And you're given the atmospheric pressure is 1 atmosphere. The temperature of the boiling point of water is 373 Kelvin. So you can do that. And we are almost coming over there. And you can see that if you observe the Dumas plus the content is going on decreasing as the temperature is rising. And that is expected. And remember, the Dumas flask is sealed from the top. Once you put in the liquid, we can seal it up, and then we can take out run the experiment. And there you go. It's almost towards the end. The water has started boiling outside. That's a good sign. The water is coming towards 100 degrees, and the liquid inside the flask is decreasing. And there we can see that when no more liquid remains, we can turn off the hot plate. Make sure of that. You turn off the hot plate only when you do not see any liquid in the flask. And now you can see that the flask is empty. And so you right click, go to the hot plate and say turn off the heat. So let it stay inside for some time in the hot, so that you don't want to crack the Dumas flask. Then after 1 or 2 minutes of cooling, you can remove the flask from the hot plate and keep it aside. And once you do that, again, you wait for 2 to 3 minutes, click on it and say remove. And there you have separated the Dumas flask from the hot water, and let it cool down now to room temperature, and keep it close to the balance so that you can remember that you have to take the weight. And there you can see the condensation occurring inside the flask. When the condensation is complete, we will know that there is no increase, and the amount will remain the same. By visually looking at it, then we can finish. So then we take the flask, put it on top, and you record the mass of the bulk and the condensed liquid. Once you do that, you can go to 4, and it tells you how to calculate the mass of the acetone. So you have mass of acetone, so PV over RT is equal to mass divided by PV over RT, or you can say mass times RT divided by P and V. You know the P, 1 atmosphere, you know the V in liters, put it in there. The gas constant, you know, temperature of boiling point is given, the mass is from 4, solve that, and you have your experiment completed. With that, I'm going to stop sharing, and